This is the Unit 6 review for Mathematical Decision Making for Life. So what I'm going to do is I'm going to work every problem on this review sheet for you, and then you're going to be able to use this review sheet as a cheat sheet on the chapter test or unit test. So you're going to want to follow along with me. You're going to want to make sure you write down everything I do. And if you have questions, go ahead and email me or let me know that I can send you another video and help you get those answered. So number 1 says, create a box and whisker plot. The data set below gives the numbers of home runs for the 10 batters who hit the most home runs during the 2005 Major League Baseball regular season. So really we don't care about much anything of that except for the actual numbers that they gave us, and that it asks us to find a box or make a box and whisker plot. So if you remember, when we do a box and whisker plot, there's a few things that we need. The first thing that we need is we need the median. We also need the maximum, the minimum. We need quartile 1 and quartile 3's values. If we know those things, then we can totally just draw our box and whisker plot. So the very first thing that I want to do is I want to write our numbers in order from least to greatest. That way we can find the median, the max, the min, those kinds of things just by looking at our set of data. So I actually think that these numbers are in exactly opposite order of least to greatest. I think these are greatest to least. So it looks like I just need to take the 39 and move it around to the front and then do everything else that same way. So 39 first, then 40, 40 again, 41, 43, 45, 46, 47, 48, and 51 for my numbers in order from least to greatest. Now in order to find the median, that's the middle that we're looking for. I'm just going to cross numbers off from the ends. That's what I like to do. So it's not those last two. Those last two are gone. These last two are gone. Gone. And then I'm stuck right here in the middle to find my median. Now the median is the middle of those two numbers, so I add 43 and 45 together and divide it by 2. But you can tell that the middle of that is actually going to be the number 44, because between 43 and 45 is the number 44. So my median is the number 44. My maximum is my biggest number. My biggest number is 51. My minimum is my smallest number, which happens to be 39. Then if you remember to find quartile 1 and quartile 2, I actually take my median or the middle from the top half and from the bottom half. So if I look at my top half from that middle down, I just find the middle number of that. The middle of that is 40, so quartile 1 is going to be 40. And then the middle of this top half up here, the middle number there is going to be 47. So quartile 3's number is going to be 47. Then you guys, it's just a matter of graphing this on a number line so that I have all of my values here. So I'm going to start here and say that's my minimum. So 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. We don't have to go up to 51. We only needed to go up to... No, we did need to go up to 51. Yeah, 51. So we're starting at 39 and going up to 51. So I should probably label those. It's hard to do that on the iPad though. So 39 here, 51 there. So 40, 41, 42, 43. We'll just label that like 43. 44, 45, 46, 47, 48, 49, 50, 51. So kind of just give some values on there. So then I'm just going to draw my box and whisker plot. So let's mark our median at 44. So our median at 44 is right here. Our maximum is over at 51, which is right here. My minimum is at 39, which is right here. Quartile 1's value is at 40. And quartile 3's value is at 47. The box goes around those middle 3 values for the box of my box and whisker plot, and the whiskers go out to the minimum and down to the maximum. So my box and whisker plot looks something like that. All right, number 2. Number 2 says, is it biased or unbiased? So we're just going to kind of, really, you guys, if you can justify your answer even on the test, you're welcome to do so. If you can be reasonable and justify, I'm going to allow whatever you do. So A says, should more money be put into athletic programs or music programs at school? Well, that doesn't seem like it's trying to sway your opinion one way or another. So I'm actually going to say that's an unbiased question. I think that one's okay. Now, it would be biased if we decided to ask that to people at a basketball game, or if we decided to ask that to people at the band concert. But because it didn't say who we were asking, I think the question itself is unbiased. B, what is your favorite soft drink? Again, the way it's written, as long as we're not asking specific groups, it seems to me like it's an unbiased question. And then C, researchers randomly choose 2 groups from 10 out of 100 volunteers and ask them the question, which brand of bubblegum do you like best? That one is definitely unbiased, even in the way that it selects its groups of people. So these were all unbiased examples, so maybe I should give you a biased example to make sure you know. So let's take A, should more people be put into athletic programs or music programs at school? And let's make that a biased question. So how about I say this instead? Money is being severely cut for music programs. Do you think more money should be put into music programs or athletic programs at school? Do you see how the little information I put at the beginning of that made that a biased question? Because I made them start thinking about how money is being spent in the first place. So that would be what would make that a biased question instead of an unbiased question. All right, number 3. Excuse me. Find the mean, median, mode, and range for the data. Now, you guys, in order to find the median, mode, and range, we really want to have those numbers in order from least to greatest. For the mean, it doesn't matter. But I'm just going to take these and rewrite them right now. So the smallest number is 2. Then I have 4, 4, 4, 4, 4, 7, and 9. So to find the mean, I'm going to add all those numbers together and then divide it by the number of numbers that there are. So I'm going to add those numbers together and divide by 9 because there's 9 numbers. I think I didn't get one written down here right. So 1, 2, 3, 4, 5, 4. So 1, 2, 3, 4, 5. Oh, there's 2 7s. That's what I missed there. I needed to write down that other 7. So what we're going to do now is we're just going to add those numbers together, and then we're going to divide by 9. So we're going to 2 plus 4 plus 4 plus 4 plus 4 plus 4 plus 7 plus 7 plus 9. When I add those together, I get 45. There was 9 numbers, so 45 divided by 9 is 5. So my answer there for the mean is 5. Now the median is the middle number. Now again, on the middle number, you guys, I like to just cross the numbers off from back to front. So the 9's gone, the 2's gone. One of those 7's is gone, the other 7 is gone. 4 is gone, 4 is gone. So the middle number there is the number 4. Then I think mode's pretty obvious in this case because mode is the number that's repeated the most. There's clearly more 4's there than any other number. And then the range, if you remember, that's that highest number minus the lowest number, which in this case would be the number 7. So there's my mean, median, mode, and range. All right, number 4. Do you think this graph representing the data shows bias? What is the graph trying to make the viewer think? So let's just read what this graph is about. It says massive increases in house prices this year. Average house price. So the first year, 1998, house prices were $80,000. A year later, in 1999, the house price was $82,000. So the price increase is $2,000. So first of all, do you think this graph shows bias? I'm going to say yes, it does. What is the graph trying to make the viewer think? Well, they're trying to make you think that $2,000 price increase in a house is a huge increase. But $2,000 in the price of a house is really not a huge increase in the first place. So what would I write down here in my explanation down here? I would say a $2,000 increase in price in a house is not a significant amount, but the graph shows that it is. So because the graph is showing that that's a significant amount, it is giving us bias towards what they're trying to get us to think. All right, question 5. Compare the two graphs. Do the two graphs show the same data? Well, let's look and see. In 2007, we're up at 82. At 2008, we're up at 84. Let's see if the other graph shows the same thing. 2007, we're up at 82. 2008, we're up at 84. Very similar graphs, exactly the same really as far as data goes, but representation is a little bit different. So do the graphs show this data? I'm going to say yes, they do. Which graph makes it look like 2008 had a significant amount of more days of freezing than 2007? Well, the one that makes a significant difference or look of difference is this one, because that looks like a huge increase. This graph makes it look like a teeny tiny increase, which it probably really is. More accurate to use this graph, but the one that shows that there's a significant amount of change would be that first graph. All right, number 6. Determine whether the data set is a population or a sample. Explain your reasoning. Now remember, a population has to include every person in that group. A sample is choosing some of the people out of that population group. So the age of each state governor, if we do every state governor, then this one is going to be considered a population. Number 2, the speed of every 5th car. Because we are not doing the entire group right there, that automatically tells you that this is going to be a sample because it doesn't take the whole group. Number 3, the annual salary for each employee at a company, because they're doing all of them, it's a population. Number 4, the number of pets in each U.S. household. Again, asking every household makes it a population. So again, a population is asking everybody in the group, and a sample is asking part of the big group. Number 7, determine if the following is a population or a sample. So same question as before. A study of 33,043 infants in Italy was conducted to find a link between heart rhythm abnormality and sudden infant death syndrome. Well, I'm going to say, because it's 33,043 infants in Italy, we're not 100% sure that was all of the infants in Italy. So Italy has a huge population, and maybe that was all of the infants, but because I don't know for sure, I'm going to say that was a sample. If it would have said a study of all 33,043 infants, then I would have said population, but because it didn't say that, I'm going to say sample. Number 8, determine whether the numerical value is a parameter or a statistic. Now, the one thing you need to remember is that a parameter comes from a population and a statistic comes from a sample. So if you can remember that, it's going to be easy to tell what these are. So it says the annual salary for 35 of a company's 1,200 accountants. So 35 out of 1,200 is a sample. It's only part of the group, which automatically then makes this a statistic. Number 9, determine whether the numerical value is a parameter or a statistic. Explain your reasoning. So again, same thing as the last question. In a recent year, the average math scores for all graduates on the ACT was 20.7. All means that they took the entire population. Population means parameter. So this one is a parameter. Number 10. Decide which type of data is being collected, qualitative, discrete, or continuous. Okay, so qualitative, if you remember, it has to do with the senses. So like touch, taste, feel, that kind of thing. Discrete is counting, like 1, 2, 3. And continuous really is anything like maybe decimal point numbers or things that you can't count, like 1, 2, 3. But they're measurable, but they're not countable. So A, how you're feeling after a test. That's definitely has to do with the senses. So I'm put a Q here for qualitative. B, the time it takes to bake a cake. So you guys know cake bakes in exactly the same amount of time. So I don't think I could count it as like 1 minute, 2 minutes, 3 minutes. I think that it's going to be more continuous. Like maybe my cake takes 25.3 minutes and someone else's cake takes 28 minutes. So I'm going to say that this is continuous. C, the depth of a swimming pool on the deep end. Now, you guys, this one I think could go either way. I mean, it could be like 9 feet. Or I guess if the pool was slanted, then you could measure it way differently in each spot. So if you said continuous or you said discrete on this one, as long as you could explain to me your answer, I would be all right with that. And then D, the most popular color of shoes that Nike sells. That has to do with the senses. So that's qualitative again. All right, 11, describe the distribution of data on the box plot. If you remember, what we're looking for is where the data has the most, from the median over. So look at this amount of data here compared to this amount of data here. There's definitely more data on this side, which means this is negatively skewed. And the last problem, our very favorite thing to do this unit, was standard deviation. Actually, it's not hard. It just takes a minute to do all of the math behind. So here's our heights in inches. We're just going to fill them into our chart so that we can do all of our math. So 96, 105, 112, 87, 101, and 124. From here, it's really just a matter of filling out our data. If you remember this, X with the line over top of it means the average. That average is going to be the same number for all the entire set. So I'm just going to write it once when I get it. So I'm going to add these numbers together over here and then divide them by 6 because they're 6 numbers. So take a second, plug those in your calculator, divide it by 6. When I do that, I get 104.17. So I rounded to 2 decimal places. That's the number that I'm going to use on my set of data here. And then I'm just going to subtract those numbers because here it is the X value minus the average. And I'm going to put those values in the next spot. So 96 minus 104.17, I got a negative 8.17. 105 minus 104.17, I got 0.83. 112 minus 104.17, I got 7.83. 87 minus 104.17, I got negative 17.17. 101 minus 3.17, all right, sorry, I was saying that 101 minus 104.17 is a negative 3.17. I started saying the answer before I read the question. And then 124 minus 104.17 is 19.83. So there's that part of my box there. Now I'm ready to just square the previous column. So I'm going to take all these values over here. I'm going to square them on my calculator and put them in the next column. So negative 8.17 squared is 66.75. I'm going to round all of my answers to 2 decimal places while I do these on my calculator. 0.83 squared, I got 0.69. 7.83 squared, I get 61.31. Negative 17.17 squared, pretty big number, 294.81. Negative 3.17 squared is 10.05. And 19.83 squared is 393.23. Now, if you remember how to get our answers here, the mean we already found, it was 104.17. We found it right here in this column. The variance is when we take the average of all of these numbers right here. So we're going to add those together and divide them by 6. So take just a minute, plug those on your calculator, and divide them by 6. All right, when I did that, I got 88.67. And then if you remember, the standard deviation just takes that variance number and it square roots it. So for the next part, for the standard deviation, I'm going to do the square root of 88.67. And that's going to give me my answer for my standard deviation. And when I punch that into my calculator, I get 9.4. You guys, that's all of the stuff that we learned in this unit. So this was the Unit 6 review for Mathematical Decision Making for Life. I hope this gets you ready for your test. Thanks for watching. Let me know if you have any questions.